Hello everyone, this is Ashish, and I will be discussing one of the method which we used for scrapping the data and using it for making graph. So what we did, uh, we in this approach we strictly constrain ourselves to the Wikipedia page uh, for extracting the data for diseases. So going to the page, Wikipedia page. Uh, for here, I am searching for COVID-19 disease. As you can see that here itself uh, has a table which itself contain a lot of information, which is quite sufficient to perform graph. So focusing over this table, I wrote a code. Uh, okay, coming to the notebook. Here, what I did, I used certain libraries of Python, uh, and as you can see here, I use the URL of the Wikipedia page of COVID-19, and yeah, this page itself, code itself will, as you can see, has extracted the data of the table which is present here. Okay, and yes, passing this table through the loop, uh, you can see that here three entities are present. As you can see, what it did, it took the first entity as a disease itself in every triples you can see, and the second is the relation between this disease and the third entity. Similarly, this entire table has been developed in triples. Now this triple is saved into mm, in Excel using this code, and again using this data using Python library, that is NetworkX. I try to build graph using it. Yeah, running this block of code here. This is how the graph is built. Thank you.
So hello everyone, I'll be explaining knowledge graph generation using the Rebel model. So what Rebel is, Rebel stands for relationship extraction by end-to-end language generation. That is, we'll be going through a text, we'll be going from the end of one sentence to the end of other sentence, and then we'll be doing named entity recognition, and following that, we'll be performing relationship classification. So here is the notebook for implementation of the Rebel model. I've imported all the libraries, then I have called all the libraries, and here I have called the Rebel model or imported the Rebel model. So this one is for the named entity recognition, and this one is for the relationship classification. And then I have defined what is knowledge base class. A knowledge base class will be containing a relationship list, and relations list, it will be containing triplets of head, type, and tail. Head will be the entity 1, type will be entity 2, and type will be the relation, and tail will be the second entity. So here I have defined some functions for converting some text to knowledge base, and this is the final function that will be taking a URL and converting it to a knowledge base. So here, to identify same entities, we have defined a rule that if two entities have the same Wikipedia page, then they will be classified as the same entity only. Yes, so here we'll enter URLs in this function, and we'll be generating the knowledge bases. So I won't be generating the whole knowledge base here. So I'll remove this for loop and generate a knowledge base just for the first 1024 characters. So it will be working like this. So this is the Wikipedia page for asthma, and we'll be generating for the first 1024 characters. So here it is being generated for the first 1024 characters. Yeah, so as you can see for the asthma Wikipedia page, the first 1024 characters, this is the first entity, this is the relationship list, the relation class, how it will be defined. This is the first entity, this is the relation, and this is the second entity, that is bronchopause. Bronchospasm is a subclass of asthma. That makes sense. So using this, we have generated knowledge graphs for over 15 diseases and later compared it using the Node2vec model for two different sources, that is Medline and the Wikipedia articles. Thank you.